Welcome back to the deep dive. We are diving into chapter 6 from Chip Huyen's AI engineering. It's called RAG and Agents. This one's a good one. And it seems like everyone is really ready to move past the basics of foundation models for sure. This chapter is all about how we can give AI the information it needs to be truly effective. And that's exciting for anyone working on AI applications, whether you're an architect designing systems, an ML engineer building models, a data scientist analyzing data, or even on the product side, figuring out how to actually get this stuff out there. One of the things that fascinates me about this chapter is that it mirrors how we as humans learn. Think about it. We don't just have knowledge floating in our heads. We use libraries, we Google things, we ask experts. Chapter 6 is all about giving AI those same tools. It's like if someone asked you to explain quantum physics, but you weren't allowed to read anything about it first, you'd probably struggle. I know I would. But this chapter introduces two powerful techniques to solve this for AI: retrieval augmented generation or RAG and agents. Let's start with RAG. I'm already intrigued by the idea of giving AI a memory boost. So how does that actually work? Imagine you're building an AI for 𝗕𝗂𝗏𝗂𝗏, that fictional fashion retailer Huyen uses. You want this AI to answer questions about sales, predict trends, things like that. RAG lets this AI tap into 𝗕𝗂𝗏𝗏𝗏's entire sales database in real time. Instead of just relying on its initial training data, it can pull up specific information like historical sales of the 𝗓𝗏𝗏𝗏𝗏 and use that to make much more informed predictions. So it's like giving the AI access to Google, but specifically for the task at hand. And it goes beyond just keyword matching. A core component of RAG is vector search, which compares the meaning of the query to the meaning of the data. Think about searching for stylish hats. A simple keyword search might miss entries that say fashionable headwear, but vector search understands they're conceptually similar. Libraries like Face and Scan make this kind of search easier to implement, so you don't have to build it from scratch. That makes sense, but there's also the question of retrievers. What are they and why does it matter which one you choose? Think of retrievers as librarians for your AI. They decide which information from that vast external database is actually relevant to the question. Simpler retrievers might just look for keyword matches, which is fast but can miss nuances. More advanced retrievers using embeddings understand the meaning behind the query, making them more accurate but also more computationally expensive. So, choosing the right retriever is about balancing speed and accuracy. If your AI is answering simple questions about product dimensions, a basic retriever might be enough. But if it's summarizing complex customer feedback or analyzing trends, you will need something more sophisticated. Chapter 6 also goes into detail about evaluating retriever performance using metrics like precision and recall, making sure you strike the right balance between getting relevant results and not missing crucial information. And optimizing this process is a whole science of its own. The chapter highlights some fascinating techniques. Chunking, for example, breaks large text into smaller pieces, making searches faster and more accurate, kind of like strategically highlighting the important parts of a textbook before looking for specific information. Then there's query rewriting. Imagine someone searching for John Doe's purchase history, but the database stores names as Doe, John. Rewriting the query to account for variations like that can make a huge difference in finding the right info. It's amazing how much thought goes into making sure the AI finds the right information. But this is still within the realm of RAG, right? We're just giving AI access to information. What about AI that can actually do something with that information? That's where agents come in. And this is where things get even more interesting. Agents don't just retrieve information, they interact with the world, execute actions, and achieve goals. While RAG is like giving AI a powerful research library, agents are like giving it hands and feet, or at least the digital equivalent. Let's unpack the core components of an agent system. Planning is a big one. Unlike simpler AI systems that just react to input, agents create strategies, break tasks into steps, and figure out the best way to achieve their goal. It's not just about having information, it's about knowing how to use it intelligently. But that sounds incredibly complex. How do you even begin to teach an AI to plan? This is where techniques like milestone planning come in, breaking a big task into smaller manageable steps like checkpoints on a roadmap. The agent focuses on each milestone, knowing that achieving them will lead to the overall goal. And once the plan is in place, the agent needs a way to act. That's where tool use comes in, one of the most exciting aspects of agent systems. Agents can be given access to external tools, APIs, databases, web searches, or even physical robots. For example, our 𝗕𝗂𝗏 wouldn't just analyze sales data. It could use an API to adjust pricing based on demand, send personalized marketing emails, or generate reports for the human team. That's the power of combining planning with tool use. The chapter also talks about function calling, where developers define specific functions that the agent can use, making this integration seamless. But with all this power comes risk. What if the AI misuses a tool, like accidentally refunding the wrong customer or ordering 1,000 fruity fedoras instead of 10? Chapter 6 outlines several pitfalls. Planning failures are one. If the agent's plan is flawed or fails to account for real-world variables, things can go wrong fast. Tool misuse is another. If the agent picks the wrong tool or misinterprets instructions, the consequences could be costly. And security risks are real too. The more autonomous agents become, the greater the risk of them exceeding their programming or being exploited. This is why robust plan validation, safeguards, and potentially human oversight are crucial. We are almost talking about cybersecurity for AI agents. One wrong move could have a ripple effect. Memory is another key component. Agents need to learn and adapt. They need to remember past experiences, what worked, what didn't, and which tools were effective. Techniques like 𝗫𝗄, first in, first out, help prioritize relevant information. And of course, tool selection is critical. Agents must decide which tool is best for a given task. Should it query a database, call an API, or even interact with the physical world? Getting this right is an optimization problem in itself. We've only scratched the surface of RAG and agents, but the implications are huge. These technologies are already reshaping how we interact with information and solve problems. And while they are powerful, they must be used responsibly. That means prioritizing ethical considerations, robust safety measures, and ongoing monitoring. It's an exciting but also challenging time to be working in AI as these technologies evolve. It's up to all of us to ensure they're used for good. So, if you found this deep dive interesting, I highly recommend reading Chapter 6 of AI Engineering for yourself. There's so much more to explore. Thanks for joining me on this journey. I'll see you in the next deep dive. This video is based on my personal interpretation of AI engineering, Building Applications with Foundation Models by Huyen. It is not an official summary and all views expressed are my own. Thank you for watching. If you found this video useful, don't forget to like, subscribe, and share.